Right. So let me finish this graph data structure today. I think in the last videos we have seen up to which topics under graph. We have seen introduction to the graph and how we are going to represent the graph, even matrix representation and list representation we have seen. So how you can able to traverse the elements present in the graph, that is BFS and DFS we have seen very clearly. So next and after that, so we have to discuss about these five more topics in our graph. So let us finish this. But to complete this shortest path and minimum cost spanning tree, you must have an idea about so priority queues. That's why. So today I will give introduction to this shortest path and minimum cost spanning tree. I will implement these three programs. Then tomorrow we will see priority queues and greedy algorithms, priority queues, and the pending graph. That two topics are there. That one and then greedy algorithms. These three things we will finish tomorrow. So tomorrow we will wind up this. Okay. Now, sir, let us go for the next application. What we have here, has path. Has path. So what is mean by has path? If you take any graph, so we are going to give source vertex and destination vertex. We are going to give source vertex and destination vertex. Your task is to, we have to check is there any path between those two vertices are. That is nothing but our main concept here. Okay, we are going to check is there any path between source vertex and destination vertex. So that is nothing but what has path what we have. Now, how to implement this? So for for explaining this concept, let us take any graph. Let us take any graph. So here I am going to take a graph where this is nothing but 0th vertex. So this is nothing but a first vertex. It is nothing but a second vertex. And it is nothing but a third vertex. Okay. And this one is nothing but what? Fourth vertex somewhere like this we have. And there is a connection. Yes, a graph can be like this, no problem at all. Now I want to check, is there any path between, 0 to 4? Okay, and I want to check, is there any path between 0 to 5? These two I want to check. So there is a path between 0 to 5, right? Yes, there is a path. And 0 to 4, I think we don't have any path. Sir, path means what? We can travel from 0 to 1, and we can travel from 1 to 2, and we can travel from 2 to 5. There is a path. So how we can able to do that, I will explain. But anyway, for that, just I need to take the previous program skeleton as it is. Let us take this program, and in this you can see how to create the graph, how to add the edges, all these things already we covered. Just assume I am going to create one graph. How many vertices are there here? So I think 1, 2, 3, 4, 5, 6 vertices are there. So what are the connections? 0 to 1, 0 to 3, 0 to 3. Next and after that 1 to 2 is there. Next and after that so 3 to 2 is there, 3 to 2 is there, and we have 2 to 5 is there. That's all right. First we will print the graph. First we will print the graph. So is it going to print this graph, whatever we constructed? Let me cross check. Now you can able to see. So 0th node is connected with 1 and 3, and first node is connected with 0 and 2. Next, second node is connected with 1, 3, and then 5. Third node is connected with so 0 and 2. Fourth node is not connected with anyone, and fifth node is connected with 2. Like this we have. So now what we have to do? We are going to ask a function like has a path, where I'm going to give that a graph that is nothing but a list. I will provide source vertex and destination vertex. So you have to tell whether path is there or not. So in this example, I am giving source vertex as a 0, destination vertex is nothing but what? 5. So is there any path, sir? Yes, we have to return true. Let me check how you can implement this. Please listen carefully. DEF, I am taking has a path, where I will take a list and I will take a source and I will take a destination. Please listen carefully. In this, I'm creating one Boolean array or Boolean list with all elements as a false and length of the list. How many vertices are there here? 6 vertices are there. So all these six vertices, so we are going to initialize with the false. We are going to initialize with the false like this we have. So after this, what we have to do? Sir, yes, my list is perfectly available. Now I am going to take, so DFS utility function I am calling by passing the list and the same source and then destination. I am going to pass that DFS util function. Anyway, I am going to write that DFS util function explicitly, which is taking, so current node is nothing but what? Current vertex is nothing but what? A source. Then destination is also given. So now, in addition to this, I think current node is sufficient. I'm going to pass that visited array also. I will visit every node present in this. So visited of current will become true. So at the very beginning, which node is visited? So I'm giving this particular source node as a 0. This is nothing but my current node now. So is a current node. We got a current node. Visited of current will become, I am taking it as a true. So after this, what we have to do? We need to find out the list of adjacent nodes which are connected to this current. So which are connected to this current? 1 and then 3. How to get that? Can I say L of, okay, L is equal to, or LL is equal to, can I take L of, so current node? Yes, it is going to return all the adjacent nodes which are connected to this 0. Which are connected to 0, sir? Can I say, is it 1 and 2? 1 and 3? Yes, it will return. Now we are going to check for each I value in that list. So every time we are going to check visited of that element is equal to false. If it is not yet visited, can you please call this DSF util function recursively by passing list and then current node will become I, visited array as it is we are going to pass. That's all. Now have a look once. Sir, here we passed current node is nothing but 0. We verified adjacent nodes for that 1 and then 3. So first one we are taking 1. So is this node is visited? No, because this is 0, 1, 2, 3, 4, 5 like this. 1 is not yet visited. So what we are doing? So we are going to call L by passing 1. 1 means that node I am going to make it as a visit. Now we have to find out adjacent nodes for 1. Which are adjacent nodes for 1? So it is nothing but 2. Only one node is there, right? 2. Then we will check, is 2 is visited? No. Then please make this node as a visited. Then we have to take adjacent nodes for 3 2. Which are adjacent for 2? So 3 and then 5. Is 3 is visited? Not yet. Then make this as a visited and go for the next one. Which are adjacent for 3? So 0 and 2. 0 and 2. Sir, is 0 is visited, 2 is visited. So what are the adjacent for 5? So only 2. That is already visited. So then 3, which are adjacent for 3? 0 and 2, both are visited. Okay, you can able to see. Sir, 5 is also get visited. Like this we are going to get. Sir, when you are traversing from 0, you visited every node present in the graph except 4, you can see, right? So now after completion of this all calls, so has path method is going to return visited of your destination. So what is your destination? In this example 5. Is the fifth node visited or not? Yes. That's why we are going to get output saying true. True. Is it visited? Int object does not support item assignment. Where line number 38. What is the problem here? Visited of current is equal to true. So please check the order. DFS util.
Double equals to.
No, no, no. Method call some problem is coming. DFS util. First we are passing the graph current node visited. So graph current node visited. Here we are calling graph current node source. Here you can see we should pass visited. Okay, we should pass visited. Now you can see there is a path. That's why it is returning true. Now if I take 0 to 4, is there any path? No, right? You can see in the list that 4 is not yet visited. So output we are going to get it as a false. This is nothing but how we can able to check is there any path between two nodes or not. Are you clear with this? Please confirm. Yes, I need response from everyone. Please confirm clear up to this. Right. So next one, the next algorithm, what we have here is, see, count paths. How many paths will be there? We have to count. Okay. So now have a look once. I'm going to implement this program. For this, I'm going to take a new graph. A new graph I'm taking. So what is that graph here is, consider 0th node is there. Already, I think this graph we have seen. So which is connected to 1, which in turn connected to 2. So which is connected to 5. And here 0 is connected to 2. Okay. And it is connected to 3. No, it is connected to 4. And it is connected to 5. There is a connection. And here I am going to consider this one as a 3. Like this I have. So I'm going to give source vertex and then destination vertex. We have to find out how many paths will be there. We have to find how many paths are there. Let us see. So here I'm going to print. So print count paths. How many paths are there? We have to count. For this, I will give the list and then as usual, source I am going to give 0 and then destination is nothing but a 5. Or let me take 0 to, okay, 0 to 5. How many paths we are expecting? Maybe 3 paths, right? Because 0 to 1, 1 to 3, 3 to 5, 0 to 5, 0 to 2, 2 to 4, 4 to 5. 3 paths I am expecting. So let us see how you are going to define. So count paths. Okay, count paths are, yeah, count paths. Like this I am taking, where we are sending a list and then we are sending a source and we are giving destination. So visited is equal to, I am creating an array. Okay, I am creating a list with every element as a false with length of the vertices. So we are going to get a new vertex here. So how many vertices are there? So 0, okay, 1, 2, so 3, 4, 5, 6. Like this, total 6 vertices are there. Like this we have. So then what will happen? We are going to return. Okay, we are going to return. So count paths util. I will define another utility function where I am giving the list as well as visited as well as a source. In this case, destination is also important. So we will write that count paths util function where it is going to take the list visited and then source and then destination. Please listen carefully how we are going to write. Suppose if source is equal to destination, whatever source you have given, is it equal to destination means what can I return? Only one path will be there. Otherwise, count is equal to 0. We have to check every path. So visited of a source, I am going to take it as a true. Now have a look once in this example. What is the source, sir? 1, 0 is nothing but a source. What is the destination? 5. Now, can I say this visited of 0? So count is equal to initially 0. Is visited of source is equal to true. I am going to take. Okay, fine. This one got updated. Then what we have to do? So try to find out. So adjacent nodes from that from that source node. So how to find out? Can I take LL is equal to, okay, LL is equal to, so L of source. So which are adjacent for this? I am taking every element. Sir, which are adjacent for these? For first 0th node, which are adjacent? So I am going to get, so two nodes. For 0, which are adjacent, I am going to get three nodes, 1, 2, and then 5. 1, 2, and then 5. Now I am going to check a loop. What is that loop? For each I value in the double list, so if visited of I is equal to false, that node is not yet visited, then count will become count plus, so count path. Okay, count path of, so count path util I am calling by passing the same list. So I am passing that visited, and then I am going to, pass I comma t. Okay, now have a look once. So here I am going to check, is it visited? Is it visited? Which one? So is it first node we got, right? For I in L, so 0th node adjacent nodes are nothing but this is the list. Is I value is 1 means is visited of 1 is true, is 1 is a false, yes. Then what will happen? Count will become count plus 1. Okay, count will become count plus 1. Then what we are doing? We are trying to call recursively this count all function, I mean count path util function again. So what will happen? It is going to be called with all these. One is visited now. So is a source value is what? Now we have to pass this as the input. Source value is what? 1. So is it equal to the destination? Is it equal to the destination, sir? No, because we are searching for 5. So it is not equal to destination. Then what we are going to do? So we are going to take a count is equal to 0. Okay, count is equal to 0. Previously count value is 1. Now your count will become 0. Okay, your count will become 0. Is it going to work? Let me check. I think better we can write, okay, let it be. So 1 is equal to false. We made it as a true. And then we are identifying the adjacent nodes for 1. Which are adjacent nodes for 1? It is nothing but 0 and then 3. So 0 is already visited. So 3 is not yet visited. So make 3 as a visited and try to identify adjacent nodes for 3. So which are nothing but, so 1 and then 5. 1 is already visited. Now I am taking 5. But whenever 5 is coming, you can see source and destination are equal. It is going to return 1. So that value will be captured here. Your count will become 1. Okay. So that means we came up to this 5. So we are making that one as a visitor. So again, if you come back, you have to identify adjacent nodes for 2, which is nothing but 0 and 4. So 0 is already visited, 4 is not visited. Make 4 as a visited. Then try to identify adjacent nodes for 4, which is nothing but, so we have 2 and then 4 is there. Sorry, 2 and then 5. So 2 is already visited, 5 is there. 5 is not yet visited, and the source is equal to destination. Then we are returning 1. Your count will become 2. Then 5 is there. So what are the adjacent nodes for 5? So I think we don't have any adjacent nodes here. Okay, adjacent nodes are 3 and 4. So 3 is already visited, 4 is also already visited. So make this node as a visited. Not, we are not required to make visited, just we are going to return 1. Then your count will become 3. So total how many paths are there? 3 paths are there. At last, every time to make another step, you can make this visited of source is equal to false. So to trace out another path, we are going to take like this. At last, we have to return C. See, when you are starting with 1, we are making this node as a visited and we will search all the paths. Then after coming out from that, we have to trace for another path, right? That's why we are going to take again source is equal to false. From here, we are going to search another path because it won't traverse in this direction because 1 and 3 already we set as a true. That's why it is going to traverse in another path. Like that we have. Now let us see, really is it going to print three paths are there? So count path util is not defined. Count paths, not path, count paths. Name D is not defined. Where D we have taken? So D in the place of this, it is a destination. So it is returning only two paths. But actually, how many paths are there? Three paths are there. But see what will happen. What is your given? 0 to 5. Three paths are there. 0th node is connected to 1, 0th node is connected to 3. Have you observed 0 to 5 link is not established here? That's why it is not coming. Now you can see total how many paths are there? Three paths are there. Like this we are going to get. Now I want to check 0 to 4. How many paths are there? 0 to 4, how many paths are there? How many paths are there? You can see 0 paths. 0 to 4. There is a connection, right? But why it is showing 0? Now you can see what is the problem here. Visited of false length, count all paths visited, comma destination. If source is destination, visited of source is equal to true, LL of source. Visited of I is equal to false, count is equal to count, path visited I, comma destination. Correct only. Okay, we will see later. So let us try with another thing. 0 to 2. How many paths are there? Three paths. 0 to 2. Okay, so let us check. This is one path, this is another path, this is another path. Okay, but why for 0 to 4? 2 to 4 connection is there? No, we have not given proper diagram, sir. That is the problem what we are getting. Now see, again I will draw this diagram. 0 to 1, 0 to 3, no, 0 to 2, 0 to 2. Okay, 0 to 1, 0 to 2, 0 to 5. Next what? So first node is connected with the third node. Next and after that, second node is connected with the fourth node. Next and after that, so third node is connected with the fifth node. Next and after that, fourth node is connected with fifth node. Now you can check. 0 to 2, how many paths are there? Maybe it is going to take three paths. Now I want to check 0 to 4. 0 to 4. So how many paths are there? I think in this case also we are going to get three paths. Now I want to check 0 to 1. Sorry, in everything we are going to get three paths only, right? For example, consider I am going to break this link. Okay, so 2 to 4 there is no connection. So in such cases what will happen? 0 to 2, if you are asking how many paths will be there, I think only one path will be there from 0 to 0 to 2. So why? Because if you traverse from here, you can't come to this location. Okay, there is only one path will be there. But 0 to 5, two paths, because this is one path, this is another path. So 0 to 4 also two paths. How, sir? So this is one path, this is another path. Okay, I think how you can able to count all paths, it is very clear for you, right? Any doubts, friends?
Clear, sir.
Right. So next we will go for the next one, which is nothing but print all paths. I want to print all the paths, so one by one. Okay, now whatever we have seen, I think same program, but we have to print the path values. Let us see how you can able to do that. So in this case also, I am going to take some help of utility functions. Let us see how we can able to do that. Let us take the same example. I don't want to count, so I want to print all paths. I want to print all paths in this graph. Starting node is nothing but 0, ending node is nothing but 5. So how many paths are there? Are 0 to 4. How many paths are there? We need to check how to do that. For this requirement, Already we have seen counting, right? Same thing, we need to just add some variable and we have to traverse. So I will explain how it is going to work. So first I am going to define print all paths. Print all paths. Is the method name is correct? Yes. I am taking list and I am taking source and I am taking destination. Like this we have. So now what we have, we need to take a visited array. Okay, visited array. So where the first element is nothing but a false. Like this I am going to repeat up to length of the list. So now we are creating another new variable called path. Let us consider it is a list. So now I am calling, so print all paths. It is a utility function. It is a utility function where I am going to give the list and I will pass visited list, and then I am going to give source and then destination, as well as that path also I will send. So that print all paths util function I am going to define now. So where already parameters are given, in the same order I am going to receive. Now have a look once how you can able to implement this method, sir. Very simple. First in the path we have to append source. Suppose consider I want to print all the paths from 0 to 5. Then first we are taking a path. In this path we are trying to append 0 because this is the source node and this is the destination. We inserted source. So immediately what we are going to do, we are checking is your source is equal to destination. Is your source and destination both are same? If it is the same, try to print that path. Try to print that path. After this, can you please remove the last inserted element and return the control? Sir, is the source is 0. Is we reach to the destination? No. Then this condition won't satisfy. Now I am taking visited of so that the source will become true. I am making that node as a visited, and we are going to identify the list of adjacent nodes for this source. For each I value in that, we are checking is it visited? Is it visited? Which one is that I value is visited or not? I am checking. If it is not yet visited, please make a call to this by taking print all paths. Same thing. I'm going to make a call to this. So what will happen? Here L is the same, visited is the same. Your source will become I. Remaining things are same. Like this, we are going to call recursively. Please listen carefully what will happen. See, first we are going to see, okay, first we are going to see 0. 0 is appended to the path. Is source is equal to destination? No. Visited of source. Sir, source is what? 0. 0 is visited. I am going to create an array with first 0th node, first node, second node, so third node, fourth node, fifth node. Like this we have. So 0th node is visited. I am making it as a true. Then what we are doing? We are identifying the adjacent nodes for this 0. Which are adjacent nodes for 0? 1 and then 5 and then 2. Okay. Now take 1. Take 1. Visited of 1 is equal to false. Yes. Then try to call this function for this same requirement. Now your source will become what? 1. So is it visited? Is source is equal to destination? No. Is it visited? No. Make this one as a visited. Okay. 0, 1. Make this one as a visited. Then try to identify the adjacent nodes for 1, which is nothing but 0 and 3. 0 is already visited. 0 is already visited. Take 3. So 3 is not visited, right? Now please cross check adjacent nodes for 3, which is nothing but 1 and 5. So 1, it is already visited, so no need to tick. Sir, 5, it is not visited, but source and destination both are same, right? So now what we have to do? We have to print the path. Okay, we have to print the path. So one second, I think every time we have to append this that we forgot. 0, next node we got 1. So next node we got 3. Okay. So next we got 5. Right. So now we got path, right? So then we are going to print. What is the first path that we got? 0 to 1, 1 to 2, Sorry, 1 to 3 and 3 to 5. Sir, now after this, after printing, we are popping the last item. Which item is inserted last? 5. That will be removed. Now, is there any pending instructions? No, there is no pending instruction. So what I am doing is I will use some backtracking here. What is that backtracking is, see, visited of that source. I am going to make it as a false and then path dot pop. So visited of a source. When we are coming to 5, from which node we have traversed this 3, right? So make 3 as a unvisited, 3 as a unvisited. And after that, what we have to do? We have to pop the element. 3 also will be removed from the path. Then we have to identify another adjacent node, which is nothing but a 5. So which are adjacent for 5? So 3, 1, and then 4. 1 is already visited. Okay. So 3 for 5 adjacent 3. Okay. Which is not visited. Maybe which is not visited. We have to make it as a visited, and which are adjacent. Like that, we are going to check. So total all paths will be added here one by one, and it will print. Let me cross check. Is it printing all the paths? So from 0 to 4, how many paths will be there? Sir, you can see from the diagram 0, 1, 3, 5, 4. So in this, like 0, 1, 3, 5, 4. This is one path. What is another path? So 0, 5, 4. Suppose if there is any connection between these, so how many paths will be there from 0 to 5? Now you can see there are 3 paths are there. So if there is no connection between 2 and 4, then how many paths will be there? Only 2 paths. This is nothing but how we can able to print all the paths which are available in the graph. Are you clear with this counting and printing of all paths in the list? I mean in the graph. Please confirm everyone.
Yes, sir.
Right. So with this, I'm going to wind up today. So tomorrow we will see the priority queues concept. Okay, priority queues. And then I will demonstrate what is this shortest path, how you can work with minimum cost spanning tree. These 2 things along with the priority queues, I will demonstrate in the tomorrow's class. Okay. Right, sir. Thank you. See you tomorrow.